Welcome to lesson 1.2, square roots and Pythagorean theorem. We're still working on squares and square roots. In this lesson, you're going to be still finding squares and square roots of whole numbers, but now we're going to come at it from a different idea. We're going to be trying to find out whether something is a perfect square by looking at factors. We already know that a perfect square is perfect because the two numbers that multiply to make that square's area are whole numbers, like the square root of 16 is a perfect square because 4 times 4 gives you 16 and 4 is a whole number. We know that 10 is not because 3.2 is not, which is the times itself gives you close to 10, is not a whole number, so therefore it can't be a perfect square. There's another way of looking at it, and that's by using factors. Now we have to back up a little bit to grade 6. A factor is a number that is basically divides exactly into another number. So it divides into another number. And I'm going to use the word evenly. That means that there is no remainder and no decimal. So for example, let's take a look at 8. We know that if you had 8, the number 8, the numbers that multiply to give you 8 are 1 and 8 and 2 and 4. Remember, we do them in pairs. A long time ago we would do 1 and 8, 2 and 4, and we called this the rainbow method, if you remember that. When you get to 1 and 8 and you work your way inwards, when you get to the middle, you know that 3 is the last one. 3 does not go into 8, so therefore we know that this is all the factors of 8, 1, 2, 4, and 8. Okay? Now, let's try listing the factors of 12. So what I'll do is I'll give you a second. I want you to find the factors of 12. Okay, you should be done by now. You can just pause the recording so you don't I don't have to wait for you. The factors of 12, I'm going to do them in pairs. 1 and 12. 1 times 12 is 12. 2 and 6. 2 times 6 is 12. 3 times 4 is 12. And there's nothing in between 3 and 4, so now I know that I'm done. Those are the factors of 12. So what I'm going to do is we're going to make a reference chart for us to work from. Take a look on the next page. You're going to find a huge chart. And this chart here, if you turn your page sideways, are the factors of each number from 1 to 30. Now, I'm not going to have you, you can sit there and you can do them all, but I'm going to show them to you in a minute. But I want to show you how this works. 1 only has one factor, and that's 1. 1 times 1 is 1. 2 has two factors, 2 and 1. 1 times 2 is 2. Same with 3, 1 times 3. Now 4 is different. 4 has 1 times 4, and it also has 2 times 2. When we get to 6, it's 1 times 6 and 2 times 3. These are your factors. Now, what I'd like you to do is to go through all of these and find all the factors, and then you'll have a chart to refer to when you're doing your assignments. This chart, if you haven't had a chance to figure it out, is right here. This is what it looks like. I can't make it basically all fit on the screen at once, but you can see here I've got the chart turned sideways. This is what you're looking at. I did the first bunch for you up to 6 or 7, and then you can see here I've done 12 for you, and 11, 10 is 1 times 10 and 2 times 5, 9 is 1 times 9 and 3 times 3. We have the factors of 8 here. As you go along, you should be able to find all the factors all the way up to 30. Now that will take you a while to copy out if you haven't already done it. Just pause the recording as you're going here. Okay? Now, if you take a look and go to the next step of the lesson, it's going to ask you which numbers have only 2 factors. So going back to the list that you have, take a look at the numbers that have only 2 factors. And you'll see the list starting here. That one has 2, right? Why has this got 11 here? This should be 1 and 3. There's a mistake here. Okay? So 1 and 3. That's got 2 factors. That's got 2 factors. That's got 2 factors. That's got 2 factors. 2 factors. Okay? So you can see them as we go through. Just copy them down into your list, and you should have the following numbers. 2, 3, 5, 7, 11, 13, 17, 19, 23, and 29. Now these all have only 2 factors. Which ones have more than 2? Now, you probably could say all the rest, but I'll write them down here for you. 4, 6, 8, 9, 10, 12, 14, 15, 16, 18, 20, 21, 22, 24, 25, 26, 27, 28, and 30. Okay? Now, when you take a look at the list, which ones have an odd number of factors? So go back here and take a look at the ones which have an odd number of factors. You notice that this is 1. That's got an odd number. Now this is 2. 2 is even, so that's not going to work. 3, it's got 1 and 3. That's even, that's going to work. 4 has 1, 2, and 4. That's an odd number. 5 is even, 2 of them. 6 is 1, 2, 3, 4. That's 4 is even. 7 is 2. That's even. 8 is basically 4. That's even. 9 is 3 there. So that's got an odd number. If you go doing the whole list, you'll notice that these are the numbers that you saw. 1, 4, 9, 16, and 25. Those numbers you should recognize from last lesson. They're referred to as the perfect squares. Which numbers have an even number? Now, I'm not going to list all of them out. There's actually 25 of them. But basically, all the rest have an even number of factors. Either have 2, 4, 6, 8, 10, or 12 factors as you look through them. Now, square numbers have a unique number of factors. If you can figure it out from below. So see if you can figure it out. What are the factors of 9? Well, we know that in 9 divided by 3 is equal to 3. So we know we have 1 and 9. And we have 3. 3 times 3. Okay? For 16, what are the factors of 16? 16 is equal to 16 divided by 4 is 4. So I'm not sure what I was doing here, but I'm going to do it. I'm going to change it a little bit here. We got 16. The factors of 16 are 1 and 16, 2 and 8, and then 4. So this is 16. Those are the factors of 16. These are the factors of 9. 1 and 9 and 3. Okay. The factors of 25. Go down here. The factors of 25 are 1 times 25, and then 5 times 5. So there is the factors of 25. You should have noticed that these are the first 3 perfect squares. Sorry, not the first 3. I guess they're 9, 16, and 25. They are perfect squares. So if you look at them, you'll notice that all the perfect squares have 1, 2, 3. 1, 2, 3, 4, 5. This has 5. This has 3. This has 3. These numbers are all odd. So all square numbers have an odd number. It's supposed to be an n. Odd number of factors. If you take a look and you go back here to the list we had earlier, remember the perfect squares. 1, odd number. 2 times 2 is 4, odd number. 3 times 3 is 9, odd number. 4 times 4 is 16, odd number. 5 times 5 is 25, odd number. And 6 times 6 is 36, but that's off our chart. So, let's take a look at the shape that pairs of factors make. If you take a look and find the factors in pairs, these are the side lengths of the rectangle that has that area. Okay? So, for example, the factors of 16 are 1 and 16, 2 and 8, and 4. Okay? Now, when we're talking about, I'm going to put 4 and 4 here. Each of these pairs makes an area with an angle of 16. So these are the shapes that you would make. The first one, 1 by 16, would be 1 here and 16 here. 2 by 8 would be something that looks like this, 2 by 8. And finally, the last one would be 4 by 4. Right? Each one of these rectangles has a side length which is whole numbers. You notice that? There's no decimals here. All right. Now, because there's only 5 of them, 5 different ones, we know that this is a perfect square. Now, I'm not expecting you to draw out every one of them. It's too long. It's easier just to put them in pairs. So, looking at this, when you find a number that forms a square with even sides, obviously, the side length is called the square of the root, square root. Okay? So, since 16 can be formed into a square, it's the 16, it can be made 4 by 4. The terminology we're going to use is that square root of 16 is 4. Now think of a tree going down to the root of the problem, the very beginning. You start with 16, the root of it, the square root of it is going down, it's 4. Okay? We know that the square of 4, this is another word you have to know, square root and square of 4, when you're asked to find the square of it, make it into the square. Well, the square of 4 is 16. Those are the two things you have to know. One's finding the square, the side length from the area, going this way, and the other one is finding the area from the side length that's going in. You have to keep those things straight in your head. So since 16 can be formed into a square with sides which are the same, 4, the square root of 16 is called, or is, 4. All right. What is the square root of 9? Well, take a look at 9. You can draw all the factor rectangles, 1 by 9 or 3 by 3. Since the square root can be formed with equal sides of 3, this is the only square that gets you 9. All right. Remember, 1 by 9 is not a square. That means that the square root of 9 is 3. So let's see if you can find the square roots of these. Now, I made them fairly easy. If you have to use your calculator to find the square root, you can. But you should know your times tables for most of them. So I'm going to give you a couple of seconds. I want you to find the square roots of these numbers. So pause the recording and do that. All right, let's take a look at what you have here. Square root of 25 is 5 because 5 times 5 is 25. The square root of 36 is 6 because 6 times 6 is 36. The square root of 81 is 9 because 9 times 9 is 81. The square root of 144 is 12 because 12 times 12 is 144. Okay, so this particular exercise right here, I'm giving you the middle. I'm asking you for the square root, the outside. So we're doing this, coming out. The next lesson is going, or the next part, is the other side of this, the opposite of it. Instead of giving you, maybe I should finish this off here. When you go the other direction, it's called squaring a number. Okay, so square root is going from 25 down to 5. Think of it climbing down the tree. You have all the branches up top, a lot of branches, and as you come down to the bottom of the tree, you have one number. Okay, and that is a single digit, and that would be, in this case, if it's 25, you have 5. So what is the square of 3? Well, if I want to make a square 3 by 3, I want to know what is the area. Well, the area of this square is 9. That means the square using 3 is 9. It's as simple as that. 3 times 3 is 9. So in here is 9. You're taking these two numbers here, multiplying them to get that number here. That's squaring it. What is the square of 4? What is the square of 5? What is the square of 13? Pause the recording and do that right now, please. Okay, now that you got that done, What is the square of 4? Well, 4 times 4 is 16. What is the square of 5? 5 times 5 is 25. What is the square of 13? Well, 13 times 13 is 169. Okay? Now, let's take another look at the square roots and squares and the symbols that math is using. All right? The square of 3 is taking the two 3's and multiplying it. So you have a floating 2 here. We did at the very beginning of squares and square roots. You should have noticed this is 3 by 3. There's two 3's. That means it multiplies to be 9. So whenever you see 3 with a floating 2, that means to multiply 3 by itself twice. So 3 times 3 gives you 9. That's how you show the square of something. Okay? So the square of 4 would be shown as 4 with little 2. 4 squared, 2 dimensions. There are two 4's. So this multiplies to be 4 times 4, which is 16. Do not fall into the trap of thinking this is 3 times 2 or 4 times 2. Okay? So the square root uses what's called a radical sign. That's what this little sign right there above the 9 is. That's called a radical sign. In fact, in mathematics later on, there's a whole unit called radicals, which you will learn in grade 10. The square root of 9 is shown as a square root of 9. That's how we say this. The symbol is the radical sign. It's asking what two same numbers multiply to give you 9. Now, that would mean 16. What times what gives you 16? That is a 4. What times what gives you 25? That is a 5. And what times what gives you 64? That is an 8. They must be the same number. Now, you can use your radical sign on your calculator to find these. Okay. Quiz time. There are 6 questions here. I'd like you to answer all 6. Pause the recording and do that now. All right, here we go. Here are your answers. 18 squared is 18 times 18, 324. 25 squared is 25 times 25, that's 625. 81 squared is 81 times 81, which is 6561. Now, the square root of 196 is 14. And 441 is 21, and the square root of 15, 376 is 124. You got it wrong, correct it. Okay, let's take a look at 128. We told you before that all perfect squares have an odd number of factors. So you need to go through and find the factors of 128. You can use your calculator, but do them in pairs or use the rainbow method. Okay? The first one is always obvious, 1 times 28. Now, if you go back to the lessons in grade 7, we had the divisibility rules. Right? So, does 2 go into 128? Well, 8 is even, so that means it does. So, 2 times what gives you 128? That's 2 times 64, and you can use your calculator to find it. Don't try to go and check every single number. Remember the method we're using. Because we know that 2 and 1 go in, we know that 28 and 64 go in. No number between 28 and 64 will go in because they'd have to be part of a decimal, 1.2, 1.3, so it won't work. If you check 3, you'll find it doesn't work. If you check 4, 4 times 32. So now we just eliminated all the numbers between 32 and 64. Check 5, it won't work. Check 6, it won't work. Check 7, it won't work. Check 8, you'll find that 8 times 16, sorry. So 8 and 16. Now comes a little bit more work. You have to try 7, 8, 9, 10, 11, 12, 13, 14, 15. You'll find they all don't work. So is this a perfect square? Let's take a look at the number of factors. 1, 2, 3, 4, 5, 6, 7, 8. So is this a perfect square? No. Why? It has an even number of factors. All perfect squares have an odd number of factors. Okay, try 212. I'll sort of put you out of your misery here. The factors are 1 and 212, 2 and 106, and 4 and 53. So, is it a perfect square? We'll count the factors. 1, 2, 3, 4, 5, 6. So the answer here is no. And if I asked you why, you'd say an odd number of factors. All right. What about 144? Well, I'll help you out here. 1 and 144. I'm going to skip these lines, they're too close together. 2 and 72, 3 and 48, 4 and 36. 5 does not go in, but 6 does. 24 times. 7 does not go in, but 8 does. 9 goes in, and 12 times 12. So, is 144 a perfect square? The answer is yes. Why? If you count up, you have 2, 4, 6, 8, 10, 11, it's like 12. You have 13 factors, and 13 is an odd number. So yes, it is a perfect square. It has an odd number of factors. Okay, so I'm going to kind of give you a couple of extra questions here. What I want to do is I'm going to give you the factors of a number, and I want you to tell me if it's a perfect square. Okay, so if you have a number, let's say for example 256, and you counted all the factors and it had an even number of factors, is that a perfect square or is that not? Sorry, I get that backwards. 256 has an odd number of factors. Is this a perfect square? The answer to that is yes. What about 9? Is it a perfect square? Well, the factors are 1, 3, and 9. Odd number, so this is yes. What about 8? 8 has 1 and 8, 2, and 4. Is this a perfect square? No. Why? 1, 2, 3, 4. It's got an even number of factors. 12. 12 has 1 and 12, 2 and 6, and 3 and 4. Is this a perfect square? The answer is no. Why? Because it has 1, 2, 3, 4, 5, 6 numbers, sorry, 6 factors, which is even, so this is no. So if it has an odd number of factors, it will be perfect. If it has an even number of factors, it will be non-perfect. Okay? If you have any questions, go back and watch the lesson. Come and talk to me. You should be working on your assignment now, and we will see you next lesson.